We'll see our line worker first start by using a cutting tool to cut the ends of the cables to be spliced. These are 15 kV 4/0 conductor cables, by the way. Now marking 9 and 10 inches down on the jacket of the cable and using a tool to cut away that outer jacket. And now peeling away the outer jacket and exposing what are called concentric neutrals, and they will be bent back and broken off to expose a black layer of semiconducting material underneath. And now we'll clean them back and leave 1.25 inches of what are called flat concentric cable, and then tape them up, and then take another measurement to cut back that semicon layer, and apply some silicone grease, and then use a semiconducting jacket stripper to peel off that semiconductive layer. Once that is done, we're exposing this pink or salmon colored insulation around the cable. We'll go ahead and peel away the tip of that so we can make our splice or connection, and slide our cold shrink termination jacket right onto the cable. Now we're going to see the shear bolt connector, which is actually what makes this splice or connection between the two sides of the cable. Tighten down. Here you see the connection between the two sides of the cable into that shear bolt connector in the middle. And tighten down the bolts on that connector. This is being done in a specific pattern as required by the manufacturer of the connector, and now you see the shear bolts being sheared off of this connector, again in a specific pattern, outer and then inner bolts. Now sand down this shear bolt connector so there's no abrasions, uneven surfaces inside the splice. Sand down the cable to make it clean for sliding on the jacket, cold shrink jacket. Here we're putting an installation compound on, using some marking tape so that we can see where the jacket itself should end. And here we are sliding that cold shrink termination jacket or joint onto over the shear bolt connector. Now notice on the far right there's a plastic release strip, which as it's pulled away allows the jacket to form down onto the cable. That's why it's called cold shrink. We're not using heat to shrink this joint. We are simply letting it compress onto the cable itself. Here we are exposing feathered concentrics on the joint, and here we are actually going to use what's called a braid tape to connect those feathered concentrics to, using a stainless steel ring, connect them to this braid tape, which we are going to see used in a moment. Here we see doubling back those concentrics onto the braid tape, using that stainless steel ring to make a nice, tight, and clean connection. And having taped in those ground braids, we can now go back to each side of the joint and tape them up. Do it on both sides of this new splice. And then use silicone tape to isolate that ground braid, securing that in position. Then we can slide the rubber ends of the splice or termination over each side of our termination. And you see here the completed splice. But we are not done yet, because now we need to tape up all 3 cables together using some arc-proofing tape, very important in order to prevent any type of electrical fire. Taping the ground braids in place here, and you'll see we use quite a bit arc-proofing tape to cover the entire cable assembly. You see above this new splice are the older graying lead paper splices that have been underground for a while. These are newer EPR insulated cables that are replacing those older splices. Here we see the attachment of the ground to perimeter ground using those braid tapes. A series of presses ground connections using a press.